Welcome back. We're solving problem 200, number of islands. We'll be doing this with DFS, depth first search, which utilizes recursion, and we're going to be working in Java. So we'll just hop right into it. The problem is stated here. Given an m by n 2D array grid, which represents a map of ones, land, zeros, water, return the number of islands. Islands are just ones that are connected and separated by water. You can assume that all four edges are water. We have the rows being m, the columns being n, and it is limited to only zeros and ones. So that will help us out with figuring this problem out. So we're going to have to do depth first search. But let's go ahead and set up some variables that we want to access. So we're going to want to know the row length and utilize that, and the column length and utilize that. Let's perform an edge case check here. All right, now we're going to define our variable. We're going to set it to 0 because we don't have any islands yet. Then we'll loop through with DFS. So what we're going to want to do here is if the grid of I and j equals 1, then it's land, and we're going to want to go into it. So we'll increment the island, and then we're going to do perform DFS. So what DFS does is essentially we can think about it like this. We're here, we don't see an island. We're going to move on. We see an island. What we want to do is we want to call a function that checks all of the neighboring spots that it has, up, right, left, down, and checks to see if it is also land. And if it is, then we'll go there and we'll call the same method and navigate until we end up at the end near water. This pops out of the stack and gets us back into the location, ensuring that we can count the amount of islands. But we also want to change the island counter from a 1 to a 0 to represent that we did actually visit it, so to speak. So DFS, we're going to pass it the grid, we're going to pass it the row, we're going to pass it the column. And now we'll write this method. Okay, so first thing with recursion is you have to have your base case first. So this is what pops it out of the recursive checks. So if row is less than 0 or row is greater than or equal to row length, or column is less than 0 or column is greater than or equal to column length, or grid row call equals 0, then we're gonna return out of this. And now I want to note, I did these in an order. So you want to check the bounds first, and then you'll do the check to see if it's a 0. If it's out of bounds and you were to put this statement, you were to put this first, you'll get an index out of bounds error and your program will crash. So don't do that. So here, we've got a return statement for if we are out of bounds or we're in water. And then now we'll mark our spot. Okay. And then we're just going to merely now we just check all the other neighboring islands. And make sure to return island counter. And we'll give it a run. Okay, so we beat 99.91% complexity and 61% memory. And this would be O of M by N, the column and the row length, or row length by column length, because it only has to iterate through the entire grid once, and it does it recursively. So that's the problem. Things I want to note are whenever you're doing DFS or a recursive statement for that matter, there is a format for it, and you have to have the base case first and other iterative steps after. The base case being first allows it to pop out of recursion. Otherwise, you could get stuck in an endless loop, and you don't want that. By easily kind of recognizing these types of problems with DFS, tree navigation, grid navigation, nearest neighbors, this will definitely help you succeed with solving these problems. I hope it was helpful, and subscribe and check in. Good luck.